Hey everyone, my name is Ivan Sharmok. I'm a solutions architect at Tigera, and today, in today's session, I'm going to talk about the GKE cluster and how to use Calico in GKE. Before I actually start, could someone confirm that you guys can see the screen, the shared screen? Okay, thank you. So today's agenda, I'm going to do a brief Calico overview and then go over the GKE networking options and design considerations. Then we'll take a look into discuss Calico in GKE, and then go through a few demo scenarios, some simple policies to secure your cluster, secure your network. And the examples will include Calico open source policies, example policies, and a few examples for Calico Enterprise, some of the features that are attributes of Calico Enterprise. And then we'll dive into Q&A. Feel free to post your questions in the Q&A screen. I do not see them as I'm going through the slides and demo, but at the end of the session, I'll be able to get to the Q&A and answer questions. So what is Project Calico, or known as Calico? That's an open source container network interface implementation of a container network interface for Kubernetes. It's known for its great speed, massive scalability, support of standard network policies, as well as some advanced network policies that Calico offers, and adoption, real worldwide adoption of the product. The ability of Calico to get such a great speed is attributed to the fact that Calico uses native Linux data plane for performance, so directly programs the Linux kernel to send the traffic, and has an ability to avoid any encapsulation. Having said that, if you've installed Calico or planning to use it, the default configuration of Calico is IP and IP, which has IP and IP encapsulation. Calico also supports VXLAN as alternative encap option, but there is an option if you do not want any encapsulation and you're looking for great speed, then you can avoid that and just have all of your pods to be to run traffic without any encapsulation. And for that, your pod network has to be routable so that packets can reach the destination. The scalability is attributed to the usage of BGP that Calico uses internally, so that allows the Calico clusters to be scaled to the limits of Kubernetes. And the support of network policies and implementation of advanced network policies allows Calico to be adopted or incorporated into managed distributions and other varieties of Kubernetes distributions by known players such as AWS, Google, Amazon, Google, Azure, and IBM. And if you look into the on-prem offerings as well, like OpenShift offers Calico in their Docker Enterprise, Rancher. All of those players have either support or offer Calico for the CNI or the policy as one of the options. And today we know of over 150,000 Calico clusters. We have a really great relationship with our community, so we get in the information. We know that it's on the lower end because some users choose not to give us that info, but of the clusters that we know of, we know that we are over 150,000 clusters on a daily basis. The community is pretty big. If you join the Slack channel, you'll see there is over 4,000 members in the Slack channel, and there are over 150 active contributors to the project. And yeah, as I said, we have a very large span, so a little bit different number in here with that we know of 1 million nodes that are using Calico. And here you can see the links where you can get either to Calico project or to the Slack community, or follow on Twitter. The Calico, the great adoption of Calico product allowed us to get on board many customers across different industries, different verticals. So you can see some from fintech to manufacturing and automotive that run very large clusters and using Calico. This also slide represents some of our Calico Enterprise users. There is a commercial product called Calico Enterprise that is built on top of OpenCore, on top of Project Calico, which provides some capabilities for enterprise customers and ease of day-to operations. So here's another slide which represents the adoption of Calico. On the left-hand side, you can see the managed solutions offered by cloud providers, EKS, GKE, AKS, IKS, as well as just upstream distribution of Kubernetes or package distros like Docker Enterprise by Mirantis or OpenShift by Red Hat. And it's also supported in Rancher, Tanzu, and others, and all the way to the VMs and bare metal machines. Calico can also run on non-Kubernetes clusters and create a policy enforcement on those nodes as well, while pulling the policies from your Kubernetes cluster. That's one of the options. There are many permutations of how you can configure it and how you can control the ingress and egress in your Kubernetes clusters and even outside of it. So jumping into GKE networking options. So GKE has several options when you create a cluster, which determines how your CNI is configured and whether network policy is going to be used. So one of those is the very basic, the default option is KubeNet, which configures uses host local IPAM without network policy. But if you create a cluster with enable network policy option, then Calico is going to be used. It's still, the IPAM is still going to be host local, but now you get Calico network policy support. So the Calico engine can be a network policy engine, can be used in that combination, in that cluster. And then the next option is using GCP NetD for the CNI. And what that allows your GKE cluster to do or to get is that all the traffic is going to be visible to every node. So it's going to loop through the GCP networking, no matter where it originates and where it's going. And I'll go through that. I have a few slides to show how it's going to go. So here's an example of KubeNet configuration. You have your GCP networking configured, then you have GCP network interface, which is represented, connects to ETH0 on each node, and then you get /24 on each node for the IP addresses of the pods. So the host local, that's what gives you that /24 on each node. And so then you get the VAF pair that connects each pod to the host, and then you get a bridge. The Linux networking is set up with a bridge to route all the traffic. So anything destined to /24, in my case on the left-hand side on node 1, for instance, anything destined to 10.2800/24 is going to go to the bridge. Anything destined to anything else is going to be routed to GCP network interface, and then outside. So by default, each cluster is configured in VPC native mode, which means that the /24 is configured, added as a secondary subnet to the GCP network interface, and therefore any traffic leaving the node and going to another node or any other resource in that subnet will be routed just normally, because GCP will handle that for you. If you're building cluster yourself, you will have to make sure that if you want to route the traffic in that manner, you'll have to make sure that VPC native is configured, or the subnets, proper subnets are configured in your VPC so that traffic can be routed. So jumping into second option when you're using Calico, when you enable the network policy and Calico gets configured with a host local IPAM. So in this configuration, you get, instead of your VAF pair is going to be represented by all the interfaces, instead of VAF, start with Kali. And in fact, you can SSH into GKE node and take a look into the interfaces on the node. So you'll see that all the interfaces in there start with Kali. And what it does, Calico basically simplifies that the configuration that KubeNet has. It removes the need for the bridge, and it plugs in directly into the kernel, Linux kernel router, and directs traffic in that way. So it simplifies the setup. You get a little bit of performance boost from that. But in the nutshell, the rest of the handling of the packets is very similar. But you also get an additional capability. That's this capability of firewalling, which is represented in Kubernetes by network policies. So now you can create network policies which are YAML-based, have YAML-based format. And once you deploy them, Calico programs the kernel, Linux kernel on each node to enforce or shape the traffic according to what you defined in the policies. And in the same way, you get your subnet. Since it's host local IPAM, VPC native is enabled, your subnet is configured as secondary on the GCP network interface. This is an example of the traffic flow, right? It gets to Calico interface, then to the router, then gets to ETH0 on the node, which is connected directly to GCP network interface, and then gets routed to the destination pod that can be located on the other node. If the pod is located on the same node, it is not going to jump all the way down to GCP network interface. It's just going to go straight through the router back to the pod, a destination pod, if it's on the same node. And here is the example of the third example with GCP and netd, where the configuration is similar. It's actually that's a mistake. The interfaces in this case are called start with GKE, I believe, and the traffic is routed in. So the traffic now, when you have intranet visibility, for instance, if the traffic is destined, pod A is trying to send packets to pod B, is going to loop all the way through GCP network interface. What that allows GKE Cluster to get is the flow logs. So all the communications from the pods are going to be recorded in GCP flow logs, and you get access to that information. Where that also plays a role with Calico is if you're using Calico Enterprise, that's the configuration you need to follow. Calico Enterprise has features built around the gathering flow logs, analyzing them, and providing additional capabilities around that. So the intranode visibility feature is required for Calico Enterprise to get the access to the flow logs. And so last option I want to briefly mention in here, if you want to leverage full capabilities of Calico and want to have Calico for the CNI and manage the IPAM and network policies, then you can configure the pure Calico cluster in GCP. That's not going to be a GKE. It is going to be an unmanaged cluster because GKE as well as other managed solutions and cloud providers, at least most of them, not all of them. There are some combinations. For instance, in EKS, you can configure Calico for the CNI, and there are ways of doing that. For GKE, at the moment, you cannot do that. So if you configure your managed cluster, leveraging GCP resources, then you can install Calico with full CNI and IPAM management. So in that case, what that allows you to do is that your pod network is not going to be relying on anything not tied to the cloud provider networking, and that allows you to choose the CIDR of whatever size you need for that. And from there, though, you'll have to either use VXLAN and IP or IP and IP if you want to use encapsulation. And Calico also can program the Linux kernel network address translation so that any packets destined to go outside of the cluster, they can be netted and the traffic can be sent out successfully. So a few considerations when you're using GKE specifically. Be aware that host local IPAM allocates only /24 per node. So each of your nodes gets the /24, and from that range, the IPs are drawn for your pods. And VPC native, which is that configures the pod IPs to be routable within the VPC. So you can access any pod using IP within that VPC, which, for instance, with option where you if the pod network is not routable, then the only option for you to access the pods is to use the Kubernetes service, so that traffic is routed through kube proxy and can be successfully routed to the pod after that. For the Calico networking, some of the things that I mentioned, if you want to use Calico policies, you have to install cluster with enable network policy flag, and also be aware that when you do that, you get a managed version of Calico. As of yesterday, I checked in GKE version 1.16. The Calico version in there was 3.8.8. So since it's a managed version, you cannot really deviate from that. You cannot upgrade it. You cannot replace that with anything you want. But there is an option for an unmanaged version of Calico. And by unmanaged, I mean that it's not managed by GKE specifically. And in that configuration, that's what you can do with intranode visibility by enabling intranode visibility, and then you can install Calico on top of that. And also with if you install in pure Calico in the cluster, once you get the Calico CNI in there, then you get access to IP pool resources that Calico manages, and then that allows you to fine tune those resources to whatever needs you have. So you can have multiple IP pools. You can configure the network policies you can segment your Kubernetes cluster based on those IP pools. You can also make sure that certain IP pools are assigned to particular nodes only, so not every node can draw from that pool, and so forth. So they allow you for better flexibility. You can also configure, for instance, Calico CNI has a capability of doing encapsulation when you cross networks. Within the same network, the traffic is going to flow without any encapsulation, and only when it's leaving the boundary of that network and going to somewhere else, then you can encap it with IP and IP or VXLAN. So for Calico network policies, two things to remember. Enable network policy just enables the managed version of Calico. Enable intranode visibility for GKE cluster allows you to get the GCP netd configuration for CNI, which allows you then to install Calico policy engine on top of that of your choosing. And there is a link in here to Calico Enterprise capabilities. This presentation is going to be shared, so you can go and review the additional capabilities that Calico Enterprise has on top of what Calico open source offers. Here's the list of upcoming events, and I'll pull this slide at the end as well, just to recap. And you can see those at tigera.io/events. We are updating that constantly, so if you see something interesting, just sign up for those. We have some of the events in European time zone. If that is more convenient for you, just look it up on the website and you'll see all the sessions scheduled for that. And circling back to Calico Enterprise, the additional capabilities of Calico Enterprise, as I mentioned, we focus on day 2 operations and some advanced scenarios for an enterprise use of Kubernetes. And you can get a trial where you don't need to even set anything up. A cluster is going to be built for you. Some of the scenarios going to be provided if you want to follow those, or if you have your own scenario that you want to try out, you can get that at tigera.io/trial. Just sign up for the cluster to be provisioned for you, and you'll get the access to that. So from here, I'll jump into demo, which is going to be hands-on from here. So all the instructions for how to set up GKE cluster and install Calico, it's all published in Tigera Solutions GitHub account in secure networking GKE repository. If you navigate there, and let me post the link in the chat probably for this. Okay, I see a few questions in the chat, so I'm going to cover those right now since I already opened it. Is Calico enabled at the node level through daemon sets or the pod level? So Calico configuration of Calico components goes through daemon sets. In Linux, that's daemon sets. Calico also has support for Windows. That configuration is a little bit different, a little bit more involved, just because of limitations in Windows Kubernetes nodes. There is no privileged access there yet, or actually there is something that is going to be G8, or maybe just recently was G8, that would bridge that gap. But as of now, for Windows, there are a few manual steps to install it and run the components as Windows services. But for Linux, that's all daemon sets. And will these slides be shared? Yes, these slides are going to be sent out. The link to the video this video recording will be shared, as well as the slides. And you'll get the links to those in the email that will follow after this session. Okay, so a few demo scenarios that I wanted to run here. And we'll start with the Calico open source in GKE Cluster. Here's my GKE cluster. And if I list all the pods in here, just to show you what I got in the cluster. So once you see the Calico node in here, you will know that Calico is running and you have the capabilities that Calico provides. And just answering one of the questions in here, Cube. So you can see in the daemon set, the Calico node, that's the component that represents the, or that has the daemon set that has Calico components in there. So the Calico node specifically, and that gets installed as a daemon set. And you also get in here, for instance, Calico Taifa. That's another component that can be used. That one is a deployment that typically used for scalability. And you can see in here, there is like autoscaler in here and horizontal, both vertical and horizontal autoscaler for that. And the reason you have that in there, if your cluster keeps expanding, and our recommendation, once you get like 50 or 100 nodes, you should start looking into scaling the Taifa pods. And Taifa is in there as an kind of acting as an edge policy cache, so that not every node goes back to the control plane to fetch the network policies, but can go through Taifa, which will talk to the control plane. So in that case, Taifa needs to pull the policies or get the policies get pushed whenever they are updated or created in the control plane, and then all the nodes that configure it to use that Taifa instance, they'll go through Taifa and fetch it from there. So that reduces the burden caused by number of nodes just trying to go and fetch the policies from the control plane. So let me jump to the, in here you'll see the instructions how to build the GKE cluster with Calico OSS, and then instructions how to build the GKE cluster that is suitable for Calico Enterprise and install that. And then once you get to the demo scenarios, there are a few scenarios for the Calico open source, and I'm going to start with this one. Actually, so here's my, okay, this is my cluster with the cluster is called Calico Webinar, and that's going to play a role once I switch it to another tab, and I'll show that after that. So first, let's deploy an application. Here's my namespaces in here, and this app creates a demo namespace. Okay, so I got my demo namespace, and I have an Nginx deployment with two replicas and two utility pods, CentOS and Netshoot. Both of those pods I'm going to use to run some commands against Nginx or some external resource, and then apply policies to those. So for that, I'll have to break my screen. To make sure that I'm connected to the same cluster. Okay. So what I'm going to do in here to show you how the policies get applied and how they affect what's happening with the cluster, I'm going to pull the logs from each of my pods. Okay, so my CentOS pod, which is in the top right screen, it's constantly curling the Nginx service. My Netshoot pod, actually, here's both of those. So, CentOS pod is curling the Google every 3 seconds, and my Netshoot pod is doing the same to the Nginx service, which is deployed within the cluster. So here you can see the Netshoot is getting to Nginx. You can see it right here. So the next thing, and one of the best practices when you're building Kubernetes clusters, if you are adopting, especially if you're adopting zero trust security paradigm, then one of the first things that typically is done is you deploy network policy that denies all the ingress and egress, and then start whitelisting the services or pods, workloads within the cluster that need to talk to other services. So here's my network policy called default deny. If I take a look into that network policy, you'll see that that's a regular Kubernetes network policy that is denying ingress, and egress within the demo namespace. So all Kubernetes network policies, they are namespaced. And for Calico, Calico has capabilities or variations of network policies that some of the network policies can be namespaced, and some can be have global scope, which means you don't necessarily need to apply that to a specific namespace, but you can apply it just to the entire cluster. And if any new namespace gets created, it automatically covers the workloads within that namespace. So now if I deploy my network policy, so you can see that both of my pods stopped getting the data. So my Nginx is failing, and my CentOS, my Netshoot is failing to pull curl Nginx, and my CentOS pod cannot curl google.com. So the next thing that I'm going to do is to allow CentOS pod to allow egress for the CentOS pod. One thing to note in here, when you're using Calico open source, you have to use Calico CDL to work with policies, to apply policies, or to to modify them, to fetch them. In Calico Enterprise provides the API server component that does the translation, API translation for Calico, and allows you to use kubectl to work with Calico resources. So here's my network policy that allows CentOS egress, and now you can see the my CentOS pod started is able to get to the to Google. And so here's a combination of policies. One of those allows cluster DNS, and two policies, one for Nginx ingress and the other for port 80 egress for the NetShoot. And what that allows me to do, let's take a look into that. So Nginx ingress allows me to allows the ingress over port 80 into any workload that has this label app equals Nginx, and that happens to be my Nginx is configured with this label. So you can see right here, app Nginx. And egress that's on the side of NetShoot, since I deployed the default deny for ingress and egress, now I have to list both ends for my workloads in order to connect them. So since I added ingress, I'm allowing ingress into Nginx. Now I need to create egress rule for my NetShoot pod. So in here you can see I'm allowing egress over port E for NetShoot. So let's deploy this. And you can see my NetShoot started curling the Nginx service. Okay, so this is a simple scenario just to show how you can use Kubernetes network policies to control access to and from your Kubernetes workloads. And if you take a look in here, all the policies I've used in here, these are a mix of Kubernetes network policies, like default deny is implemented as a Kubernetes network policy. If you take a look into API version, that's Kubernetes namespace or Kubernetes API. And if you take a look into policies in this 25 sample policy folder, you'll see that these are Project Calico APIs. So the network policy here are Project Calico. And what's probably worth mentioning in here, one difference that exists between the Kubernetes network policy and Calico, that's this ordering field that allows you to stack the policies against each other to prioritize certain policies to take precedence over others. By default, any network Kubernetes network policy that is deployed, it gets the order number of 1,000. So that's why I deployed this, and I know that it's going to be one of my last policies. And default deny, typically you deploy that as the very last policy, because once the traffic is dropped, there is nothing else that can. There is no other policy that will be evaluated after that. So in here, you can see my order field, I'm setting lower than 1,000, between 100 to 100. And that allows these policies to be evaluated before my default deny. So if any of these policies matches the traffic and allows it, it's going to be allowed. So now moving on to next example. So this might just to confirm. So you can see this cluster is called GKE Calico webinar. And I have my other cluster, which is built for the enterprise setup. So it's called Caliant webinar. And similar to the other cluster, if I show you Calico get pods. Let's choose, yeah. this will be better. So in here, you can see there is a slight difference in here. So you will see the netd is installed in here in this cluster. That's that's the CNI or the component of the CNI that allows that gets installed once you enable that intranode visibility. You can see a lot more components in here. Those, especially anything that starts with Tigera, that's Calico Enterprise, that belongs to Calico Enterprise. So there are more components in this cluster, but that's one of the differences. And if we take a look into cluster informations, for instance, that's one way to get your Calico version. So you'll see that this cluster is running the core version of 3.15.1, and the CNX version, which is Calico Enterprise component, is of version 3.2. So if we take a look, curl that information in our other GKE cluster, so in here you can see the version of Calico is 3.8.8. Just to show you the how you can find out which Calico version you're running in your cluster if you have one. So for this demo, I also need to deploy my application. And just to show you the namespaces in this one. So I don't have my demo. Here's my demo namespace. Okay. So while my pods are getting created, I'm going to create a tier. So before I do that, let me briefly show you the UI for this. I'm using a service account. This is a Calico Enterprise Manager UI. I'm not going to dive into it. We have other sessions that are going in detail through it because it will take me some time to walk through it. But I'll show you some of the screens in here and briefly describe some of this, some of the graphics that you have seen. So as you log into Calico Enterprise Manager, you get these screens that show you connections and allow bytes and packets, as well as denied bytes and packets at the bottom. You can see number of policies, the endpoints and nodes for your cluster. And this packet by policy histogram shows you the evaluation of policies over the traffic live. So this gets updated every few seconds or so. So you can see, for instance, red bars showing you that there are some policies that deny certain traffic. And so here's a representation of the policy board view, where you can see the policies deployed within your cluster. And one of the attributes of Calico Enterprise is that you have this support for custom tiers. So in Calico open source, everything is stacked against, there is only one tier, or technically there is none, but in this representation, that would be this default tier where all of your policies are stacked. In Calico Enterprise, you have ability to create these tiers, and then you can imagine you can map those to your org structure, where different teams would manage, like security team or platform team would come in and manage only policies within their tier, but not others. So this allow Tigera, that's the tier that when you install Calico Enterprise, it sets up the rules or the policies for Tigera components or for Calico Enterprise components. So let me do this. Copy the wrong thing. Okay, so what I'm going to do, I'm going to create another tier in here. which is also, it's all YAML-based, all the components. So you can see that simple, kind of similar how defining namespace for Kubernetes, which is different API, different type. And you also have the order field for the tiers, so you can stack those or sort those in your UI in Calico Enterprise. So you can see I put the order 200 in here. So you can see, for instance, here's my order. So the next thing I'm going to do is similar to what I've done for just get logs from CentOS and get logs from Medshoe. Okay. And so here's an example of default deny policy, but now it's implemented. If before I used Kubernetes to implement default deny, in this case, this is Calico default deny. So it's very similar to the other one. The only difference, I have an ability here to put the order, and selectors are much more sophisticated, provide you greater flexibility on how the policy can be applied to which endpoints. So once I implement it, my traffic stops. Now I'm going to use these policies to, for instance, I'm using the DNS policy for my CentOS pod is going to Google. So these policies, I'm going to deploy them and then go show you what they do. So now you can see CentOS is allowed to access Google, but now if we take a look into this policy, this is called DNS policy. And the reason for why it's a DNS policy, because I'm matching against a specific domain instead of a specific pod within the cluster. From this view, from the policy view, it's maybe not as obvious, but if you take a look into this this rule that allows domain external, and then if we navigate to the global network set, so what I've used for this is another object that Calico supports that's global throughout two types, network sets and global network sets, which allow you to define a list of resources or endpoints that you want to manage, and then either allow or deny access to those. So because this resource has, I can assign labels to this, then to these resources, I can reference them later in my policy. So which allows me, for instance, I can stack a bunch of domains that I would allow access to, and then create a global network set with IP addresses. I called it public IP range. You can see it's like from 1 to 200 something, all public networks. And I can deny my pods to egress to those public IP addresses. And that's exactly what is done in this policy. So you can see I'm allowing, for instance, I'm allowing the DNS access over port 53 within the cluster. I'm allowing access to Google, but I'm denying access to anything else. So just to validate that and make sure that it's all configured correctly, let's do this. Let's take a command. So I'm from my CentOS pod. With this command, I'm curling Google, right? So, and look what happens if I try to Google to curl something else. For instance, if I go to Apple, now I cannot get to Apple DP. Or if I pretty much anything else, if I try to together, the access will be denied just because my policy explicitly bans access to this public IPs. Yeah, and if I deploy this to policies, that's policies from previous example, I'll allow. Okay, so this was the last thing that I wanted to show in this session. Again, all this information is accessible. You can get the entire guide on how to set up GKE cluster and some example policies. Try it out yourself. It's in on GitHub under Tigera-solutions account and the repo secure network in GKE. Just to get back to our schedule, we will host more sessions, and in fact, we scheduled to have 2 sessions per week. So you can look through the agenda. Some of those, this list constantly gets updated. Go to tigera.io/events to get the latest information. And now let me take a look at the Q&A. Yep. Okay, so there is a question in the chat. What are other differences between KDS default network policy and Calico network policy other than order? Why to use Calico network policy and not KDS network policy? So one of the differences, and I would, in my opinion, I would say whenever you can use and achieve whatever you're looking to do with standard Kubernetes network policies, I would encourage you to use those. That just for simplicity reasons, and some people choose to have they don't want to be dependent on any specific implementation, any specific vendor who implements the policies. They choose to go through standard network policies, but in some cases, you just cannot achieve certain things. So one example is, for instance, DNS network policy. Kubernetes just does not support that. You cannot do that. The tiers, for instance, that's also the attribute of Calico Enterprise, but the tier is one capability that enterprises use a lot, just because as you get to the scale and start managing tons of workloads, it becomes very difficult to kind of manage those policies and orchestrate. The order is one of the features that can help you to stack those policies in the right order. But then you also have, for instance, network sets. And by the way, network set, the regular network set, it's a namespace resource, which means only namespace network policies can reference it. And global resources like global network policy and global network sets, they are designed to work together. So the global network policy cannot reference regular network set. It has to reference global network set and vice versa. So Calico provides multiple objects that allow you to be more sophisticated how you design your policies and how you achieve the compliance that you're looking to do. With Kubernetes network policies, the capability is somewhat limited, but if you can achieve what you're looking to do, then by all means, I would recommend you using the standard policies. Is Calico IPAM run on the master node only? So the Calico IPAM leverages etcd or actually can leverage etcd or Kubernetes KDD, we call it, which effectively ends up in the etcd of Kubernetes. So Calico IPAM it's an attribute of the control plane. So the control plane would store information about all the IPs distributed or IP ranges and assigned or utilized IPs. So yes, it would be on the, since it's a part of the control plane that runs on the master nodes, then yes, that the information will be stored within the Kubernetes control plane nodes. Okay, we have about 1 minute left. Post your questions if you have more. I'll try to answer those. For the info, all the info on this, again, head to Tigera Solutions, GitHub account. And besides this, you'll see we had sessions, similar sessions for AKS and EKS. So if you are looking to do multi-cloud deployments, then you can get some info on how to configure your AKS or EKS cluster. And I briefly mentioned that there are some capabilities for Calico CNI to be used with managed solutions. So one of those is EKS. In EKS, there is a way to install Calico to be used as a CNI. I think recently there was an issue found which we are looking to address with like one specific feature or capability that wasn't working on EKS, but the reason that customers choose to use Calico CNI and EKS is for because they run into IP exhaustion. That's a very typical case when you start running your clusters at scale, when you start moving a lot of workloads in there. So it's quite easy to exhaust the VPC range that you've allocated. And what Calico CNI allows you to do, because it's not tied to the underlying cloud provider VPC networking, it allows you to manage the IP addresses independently, which means you can select whatever range you need in there. Okay, thanks a lot for attending this session, and hope to see you in next sessions. Have a good one.